Hello everyone, this is Dr. Prashanth and welcome back to Biostatistics lecture series. In this video, I will discuss about the concept of p-value and statistical inference. To start with the introduction, statistical analysis refers to the analysis of data collected to derive patterns, trends or other meaningful conclusion. It is concerned not only with summarizing data but also with investigating the relationships between the variables. The main aim of statistical analysis is to use the information gained from the sample of individuals to make inferences about the population of interest. So basically there are two approaches for statistical analysis. One is estimation, that is through confidence intervals, and other is hypothesis testing using p-values. So now let's understand what is null and alternate hypothesis. Usually any two groups being compared in the study are assumed to be same until proven different. The proposition that the two groups are equivalent is known as the null hypothesis. That means no difference. So the alternate hypothesis to null hypothesis is the two groups being compared in the study are different. So that is, there is some difference. Let's see some examples. Oral contraceptives do not cause breast cancer. That is null hypothesis. Oral contraceptives may cause breast cancer. That is the alternate hypothesis. Similarly, the proportion of overweight in men and women is equal, or also in terms of difference, we can say that the difference in the population of overweight in men and women is 0. So this is null hypothesis because we are telling that there is no difference. So what will be the alternate hypothesis? The proportion of overweight in men is lower than women, or also in terms of difference we can say that the difference in proportion of overweight in men and women is not equal to 0. So this is the alternate hypothesis. So it can also be more, okay, because in this example I said that overweight in men is lower than women. It can also be overweight in men is more than women, or simply you can say it's not equal. So what is the p-value? A p-value can be interpreted as the probability of obtaining the observed difference or one or more extreme if the null hypothesis is true. So in simple words, it is defined as the probability under the assumption of no effect or no difference, that is null hypothesis, of obtaining a result equal to more extreme than what was observed. The P stands for probability and measures how likely it is that any observed difference between groups is due to chance. It tells us the strength of the evidence against the null hypothesis, which is, we usually say there is no difference by using null hypothesis, right? So the p-value tells us the strength of the evidence against the null hypothesis that the true difference in the population is 0. So if the p-value is less than or equal to significance level, which is usually taken as 0.05, then we call it as statistically significant. If the p-value is more than the significance level, that is 0.05, we say it is not statistically significant and indicates strong evidence for the null hypothesis. And now coming to confidence interval and p-value, let's see the difference between these two. A confidence interval gives us the range of values within which we are reasonably confident that the population difference lies. Okay, we have already discussed in the last chapter. Whereas the p-value tells us the strength of the evidence against the null hypothesis that the true difference in the population is 0. So that's the main difference between the confidence interval and p-value. So let's understand this with examples. Example of confidence interval. We are 95% confident that the mean systolic blood pressure in the population of all individuals lies within the interval, that is 126.67 to 127.92. You already know how to calculate the confidence interval, right? Using the formula. Similarly, the example of p-value. So you got a p-value of 0.0237 or 2.37%. So what does it mean? It means there is a 2.37% chance of your results being random or having happened by chance. So that is the meaning of p-value. And now coming to steps of hypothesis testing. So there are basically 5 steps. In the first step, you need to state your null hypothesis. Now you know what is null hypothesis, right? So no difference. And then you need to state your alternate hypothesis, okay? And in the third step, you need to choose a significance level alpha. Usually we select 0.05. And in the fourth step, conduct the study, observe the outcome and compute the probability of observing your results or results more extreme if the null hypothesis is true. It's nothing but the p-value. Calculate the p-value. And in the final step, use your p-value to make a decision whether to reject or not reject your null hypothesis. Okay. So for example, if we use a sample of 216 PBC patients, that is primary biliary cirrhosis, to evaluate the null hypothesis that the mean serum albumin in all the PBC patients is 33.5 gram per liter. Okay. The mean serum albumin in the sample was given as 34.46 gram per liter. And the standard error was given as 0.397 gram per liter. So let's break down the question, write down the values. And so what is the null hypothesis in this case? They are asking us to test 33.5 gram per liter because they have already given to evaluate the null hypothesis that the mean serum albumin in all the PBC patients is 33.5. So we know the null hypothesis, and the alternate hypothesis will be not equal to 33.5. So what is the significance level? We will choose 0.05. And what is the next step after choosing the significance level? Calculate the p-value by using the test statistic. So what is the observed value in this case? That is 34.46 minus what is the null hypothesis? That is 33.5 divided by what is the standard error in this case? 0.397. So all the values we substitute from the question. Okay. So you got the test value as 2.42. So by using the test value, we can calculate the p-value. So in this example, the p-value comes to be 0.0155. So what does it mean now? Test statistic of 2.42 or more with arrays with a probability of 0.0155 if the null hypothesis is true. So this is a interpretation. And the p-value is obviously less than 0.05, right? Because we got 0.01. So in this case, we reject the null hypothesis. And now coming to p-value interpretation, we have already discussed if the p-value is less than 0.05, we say statistically significant. And if the p-value is more than 0.05, we say it is not statistically significant. So there is one important point in not statistically significant column, that is, if p-value is more than 0.05, we cannot say that null hypothesis is true, but we can say that there is no enough evidence to reject it. Okay. And in the below table, I have given different p-values and the interpretation for each value. Please go through them. And now coming to type 1 and type 2 errors, till now we have discussed about the null and alternate hypothesis, right? So based on that, there are two possible errors which can occur while using p-value to make a decision. That is type 1 error and type 2 error. So what is a type 1 error? If the null hypothesis is actually true and you reject the null hypothesis, okay, then we get the error that is called type 1 error. But if the null hypothesis is actually false in reality, but you fail to reject the null hypothesis, then the type of error is called type 2 error or beta error. We call type 1 error as alpha error. And now let's see the difference between one-tailed and two-tailed test. The p-value is the probability of obtaining a result at least as extreme as the observed result when the null hypothesis is true. So such extreme results can occur by chance equally often in either direction, that means right and left. So we usually calculate two-sided p-value. But in some cases, we consider that the real difference can occur in only one direction. So that an observed difference in opposite direction must be due to chance. So in this case, that means one-side test, the alternate hypothesis is restricted to effect in only one direction. So we calculate one-sided p-value by considering only one tail of the distribution of the test statistics. So to make it more simple, two-tailed test if our hypothesis include not equal to. So when we use the word not equal to, it can be less than or more than. So we try to look into either sides of the graph. Okay. So that is called two-tailed test. But in one-tailed test, we will be clear that, we will say that it is less than or more than. So if our hypothesis includes only either more than or less than, we look at only one side, either left or right, right? So that is called one-tailed test. Let's see some examples. Children born prematurely have lower mean IQ than the general population. So we are very specific. We are telling that it's lower. So mu less than 100. So it is one-tailed test. In the same example, children born prematurely have mean IQ not equal to general population, or if we say there is some difference from the general population, that is mu not equal to 100. So it can be more or it can be less. In this case, we use two-tailed test. Thank you.